Fresh data regarding 3I Atlas has just been highlighted by Avi Loeb, thanks to amateur astrophotographers who are currently securing the highest resolution images of the object to date. What is appearing in the frames captured between November 16th and 17th is triggering intense scientific debate regarding the physics governing this body. In this breakdown, we are going to analyze exactly what is going on with 3I Atlas based on the facts. From our vantage point, 3I Atlas vanished behind the sun in late October, leaving us blind to its movements for roughly 2 weeks as it was obscured from ground-based observation. The silence broke on November 6th, when the Virtual Telescope project managed to snag the first post-solar images. Despite the comet hugging the horizon at a mere 12-degree elevation, a notoriously difficult angle, a forming ion tail was just barely perceptible. To understand the current situation, one must look at the timeline of observation. From the perspective of Earth, 3I Atlas vanished from the night sky in late October 2025, dipping behind the sun in a celestial conjunction that rendered it invisible to ground-based optical telescopes for roughly 2 weeks. This period of silence was tense. The Perihelion passage, the point closest to the sun, is a moment of truth for comets. The intense gravitational, tidal forces and searing thermal radiation can rip fragile icy bodies apart. The silence broke on November 6th, when the Virtual Telescope project succeeded in capturing the first post-perihelion images. These early observations were a triumph of technical skill. At the time, the comet was hovering a mere 12 degrees above the horizon. Observing at such a low altitude involves peering through a thick layer of Earth's turbulent atmosphere, which usually distorts celestial objects. Despite these abysmal viewing conditions, the initial images revealed that the object had survived. Even through the atmospheric haze, astronomers could detect the faint, embryonic formation of an ion tail. As the days progressed, the viewing geometry shifted favorably. On November 9th, the angle of observation relative to the sun improved, allowing for much higher contrast images. With the comet climbing higher into the morning sky, the obscuring effects of the nucleus, which had previously blocked our view of the tail during the closest solar approach, diminished. The tail began to fan out, becoming an undeniable feature of the object. However, this was just the prelude to a far more baffling revelation. By November 11th, 3I Atlas had developed into a spectacular visual object. New imaging data revealed a massive ion tail, a stream of ionized gas glowing under the bombardment of solar ultraviolet light, stretching for approximately 1 million miles across the deep background of space. The orientation of this primary tail was entirely consistent with standard cometary physics. It pointed northeast, a direction directly opposing the sun. This behavior is dictated by the solar wind, a relentless stream of charged particles blasting outward from the sun at over 800,000 miles per hour. This cosmic gale strips ions and dust from a comet and pushes them strictly away from the star. However, the November 11th imagery contained a detail that sent ripples through the astronomical community. Alongside the million-mile ion tail, faint but discernible data showed a second structure, a spike or tail pointing in the completely wrong direction. It appeared to be pointing roughly toward the sun. In the days that followed, this was confirmed to be more than a smudge on a lens. On November 15th, an astrophotographer in Thailand utilized specialized filters to capture a high-fidelity image that showed this feature in startling clarity. It revealed a bright, well-defined anti-tail opposing the primary tail. This culminated in the observations of November 16th, which may stand as the definitive visual record of the anomaly. In these frames, the detail is stunning. The object exhibits a bright central coma, the atmosphere around the nucleus, and a complex array of appendages. We see the primary tail sweeping back as physics dictates, but we also see distinct sunward-pointing jets, narrow collimated beams of material fighting the flow of the solar wind. To grasp why a sunward-pointing tail is so problematic, we must review the mechanics of the solar system. A comet is essentially a dirty snowball. As it nears the sun, the heat causes volatiles, or ices, to sublime, releasing dust and gas. Because the sun is a massive fusion reactor, it exerts pressure on everything around it, not just through gravity, but through radiation pressure and solar wind. Radiation pressure and solar wind act like a leaf blower. Therefore, comets have tails that trail away from the sun. When a comet is moving away from the sun, it effectively flies into its own tail. Astronomers have documented anti-tails in the past, most notably with Comet Arend-Roland in 1957 and Comet Pan-STARRS in 2013. However, historically, these have been optical illusions caused by projection effects. When the Earth passes through the orbital plane of a comet, the heavy dust trails left behind the comet can, for a brief window of time, appear to point sunward due to our specific line of sight. It is a trick of perspective, similar to how parallel train tracks appear to converge in the distance. However, the data for 3I Atlas does not align with a simple optical illusion. Multiple observatories from different latitudes and longitudes looking at the object over successive nights have confirmed the physical reality of this sunward protrusion. The anti-tail is distinct, bright, and persists in a way that suggests it is a physical structure of material moving toward the star, rather than a trick of the light. This leaves the scientific community with the burden of explaining how material can flow upstream against the solar wind. Hypothesis 1. The massive dust particle explanation. The heavy dust explanation for 3I Atlas's unusual sunward-pointing tail proposes that the comet must be ejecting particles far larger than typical comet dust, around 100 micrometers rather than the usual 1 micrometer, so that solar radiation and wind cannot push them away from the sun. However, such particles are about 1,000,000 times more massive than standard dust grains, and producing enough of them to account for the comet's observed brightness would require an extraordinarily high mass loss rate, roughly 100 times that of a normal comet. If 3I Atlas were truly ejecting that much heavy material, its nucleus should be rapidly shrinking or breaking apart. Yet observations show no such change, leaving the heavy dust hypothesis inconsistent with the comet's actual appearance. Hypothesis 2. The sublimating ice fragment explanation. The second major natural explanation suggests that 3I Atlas's anti-tail is made not of dust, but of large ice chunks, ranging from softball to boulder size, hurled sunward during an intense outgassing event. These massive fragments could initially resist being pushed back by the solar wind, and as they move toward the sun, they would rapidly sublimate, producing a bright halo of gas and crystals that appears from Earth as a glowing sunward tail. However, this idea faces a Goldilocks problem. Chunks too small would vaporize almost instantly, leaving no sustained structure, while chunks too large would sublimate too slowly to generate the observed brightness. For the theory to fit, the comet would need to eject a finely tuned stream of ice pieces all at exactly the right size to shine brightly yet persist long enough, a highly specific and improbable set of conditions. Hypothesis 3. The artificial origin hypothesis. The third and most controversial explanation is that 3I Atlas may not be a natural comet at all, but an engineered object whose anti-tail is actually a propulsion plume. Drawing on ideas previously discussed for Oumuamua, This theory notes that human-made spacecraft can produce comet-like tails when venting fuel or firing thrusters, creating bright, narrow plumes without the large gas clouds typical of real comets. If 3I Atlas were using thrusters to maneuver or decelerate, the resulting high-velocity exhaust would naturally form a straight, sunward-pointing beam, unaffected by solar wind, neatly resolving the inconsistencies found in natural explanations, and matching the sharply defined jets observed on November 16. Implications of structural integrity and persistent activity. The argument for the object's anomalous nature is bolstered by its remarkable structural integrity. As mentioned, comets are fragile aggregates of ice and dust. When they pass perihelion, the thermal shock is extreme. The expansion of heated gases inside a comet often causes it to shatter, as seen with the famous comet Eisen, which disintegrated upon grazing the Sun. 3I Atlas, however, endured the fiery cauldron of perihelion and emerged with a single distinct nucleus. The November 11th and 16th images show no signs of fragmentation, calving, or partial disintegration. It is a solid, cohesive object. Furthermore, there is the question of energy persistence. Natural comets are solar-powered engines. Their activity, the jets, the coma, the tail, is driven exclusively by solar heating. Therefore, as a comet moves away from the Sun, its activity should drop off according to the inverse square law. Twice the distance means 1/4 the energy. We expect comets to quiet down as they retreat into the cold vacuum. However, observation suggests that 3I Atlas remains vigorously active even as its distance from the Sun increases. It continues to sport complex tail structures and high luminosity. If an object maintains high energy output while moving away from its external power source, the Sun, one must consider the possibility that the power source is internal. Natural rocks do not have batteries or reactors. They cool down when removed from heat. A technological object, however, brings its own energy, sustaining activity regardless of its proximity to a star. As 3I Atlas journeys back toward the outer solar system, it leaves a wake of unanswered questions. The standard models of astronomy, involving dust mass loading or sublimating ice, can partially explain the data, but only by stretching the variables to their absolute limits. The presence of a stable, bright, sunward-pointing anti-tail that defies solar wind dynamics, combined with the object's miraculous survival of perihelion and sustained activity levels, paints a picture of an object that refuses to fit neatly into our snowball boxes. We are fortunate that technology has democratized astronomy. 50 years ago, this event would have been visible only to a select few at major government observatories. Today, a citizen scientist with a $500 telescope setup can contribute crucial data to the debate. Organizations like the Virtual Telescope Project are facilitating live global observations, allowing the public to scrutinize the evidence in real time. Whether 3I Atlas is a 1-in-a-million alignment of icy debris, a freakishly dense dust cloud, or an artifact of interstellar technology navigating our system, it serves as a humbling reminder of our limits. The universe is under no obligation to be simple, and as this object fades into the dark, the debate over its identity is only just beginning.